Hey everybody, thanks for tuning in today. Today we're going to talk about three-dimensional figures, which will lead into our study of surface area and volume of those 3D figures. So let's just start today by talking about the three-dimensional figures, or solids, that can be made up of flat or curved surfaces. Each flat surface of a three-dimensional solid is called a face. All right, so if you look down at our picture down here, this figure actually has 6 faces if you count it all the way around the sides. Starting with this red one on top, that's one of the 6 faces. Okay? An edge is a segment that is made up of the intersection of 2 faces. So you see this red line on the right side over here. That's called an edge. And again, this has a lot of edges. This particular figure has 12 edges, 4 on the top, 4 on the sides, and 4 on the bottom. And finally, a vertex is a point that 3 faces or more intersect at. So this point in the bottom here is one of our many vertices, vertices being a plural of vertex. This shape has 8 vertices. One of them is in the bottom right corner there. Here are some basic three-dimensional figures that you must be able to recognize fairly quickly. Okay, the first one has 2 parallel congruent faces called bases connected by parallelograms. This is called a prism, P-R-I-S-M. The next one is 2 parallel congruent circular bases and the curved surface that connects the bases. So this is kind of like a circular prism, which has its own special name, a cylinder. The third one there, it's a polygonal base, so any polygon is a base, and triangular faces that meet at a vertex. This is called a pyramid. And the last one for now is a circular base and a curved surface that connects to a vertex. So this is kind of like a circular pyramid. Oh, it's a special name called a cone. So we need to be able to recognize those kind of shapes almost instantaneously so we can know how to find their surface areas and volumes. Here's a picture of a bunch of different prisms and pyramids that we'll see. There's obviously many more than these, but we can see a couple different options. Prisms and pyramids with triangles, rectangles, pentagons, or hexagons as their base. Also, a rectangular prism where all the sides are the same shape, they're all squares, is called a cube. So a cube is a special rectangular prism. All right, so we're going to start here by classifying this figure and naming the vertices, the edges, and the bases. All right, so the classification of this figure would be a rectangular prism. So some of you might say cube. It might be a cube. We don't know for sure that all the sides are the same, but it could be a cube. But we know for sure it's a rectangular prism. Okay, that rectangular prism here has 8 vertices in any particular order. Doesn't really matter what order they're in. Edges, there are a lot of edges here. This one has 12 edges. Okay, and again, in any order, but just make sure that each edge has a segment hat over it, because these are all segments. And the bases. Now, don't get locked into this where the bottom has to be a base. A bottom could be the base here. So your bases could be the top and bottom. It could be the right and the left, or it could be the front and the back. It really doesn't matter for a rectangular prism. Okay? So for what we're going to do here, we're going to call the top and the bottom bases. But again, they don't necessarily have to be the bases. All right, here's another figure. So the classification of this one is a pentagonal pyramid. So it should be pretty obvious it's a pyramid. What kind of pyramid? You look at the base. The base is a pentagon. So this is a pentagonal pyramid. All right, a couple less vertices this time. Only 6. Again, any order is fine. Edges as well. There's definitely a couple less here. This time we have 10 Again, make sure that you have segment hats over all of them. So the 5 around the pentagon and the 5 that extend close to F. And bases, pyramids only have one base. And this shape is a pentagon, so it's pentagon A, B, C, D, E. Here's another one. This one's a cone. This one only has one vertex, and that is vertex N. M is not a vertex. M is the center of that circle. There are no edges. There are no edges in a cone. And then finally, bases. There's only one base to a cone. It's a circle, so we call it circle M. A couple more things in this section. The next one we're going to talk about is a net. So a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. So picture for me a cardboard box, and if you were completely flatten that cardboard box, taking all of its sides and flattening them out, that would be a net. If you turn that three-dimensional figure into a two-dimensional picture, that's what's called a net. Okay, so here we have a couple nets. We want to identify what they are if we put them back together into a three-dimensional figure. Some of them are a little bit easier than others. For example, 4A, that one should be pretty obvious, with two circles for bases and a rectangle that kind of wraps around those circles. This would be a cylinder. The next one also should be fairly simple. If you took that middle triangle as the bottom of the figure and fold the other triangles up, this would be a triangular pyramid. C might be a little bit more difficult for us to see what happens here, but this, if you folded that circle around, fold that semicircle around the circle, this one would actually turn into a cone. All right, lastly, the last thing we're talking about here is cross sections. A cross section is the intersection of a three-dimensional figure and a plane. So the way I always say to think about this here is take a three-dimensional figure and think of a plane as like a really sharp knife, and you were to cut that three-dimensional figure at some point, okay? Now in part A, we're essentially laying that knife on top of the cone. So that is just going to intersect at a point. But for point B, we're chopping that pyramid almost in half. So the cross section would be what shape? It's kind of outlined for you there in red. It would be a pentagon. It's a pentagon because it is a pentagonal pyramid. All right, in part C here, if you were to take a cone and chop it straight down the middle and pull those sides apart, what shape would you see? You would see a triangle. All right, that's it for our opening into three-dimensional figures. Next time we'll come back and we'll start learning how to find the surface area of these figures.